welcome everyone. So thank you so much for coming. So you all know why you're here. I have been spending the last 8 months or so creating a whole new language aimed at solving modern programming problems. Of course, it's actually been a pretty big trend lately. There's been a lot of languages created lately. And definitely, this kind of outlines kind of most to all of my goals with Wake. So there's a lot of languages out there that are very slow, and people sort of build with them and then sort of have to drop them and move to different ones because they're too slow. Or they get embedded into the infrastructure and do things like have to create just-in-time compilers with half their company's resources. So it's also expressive, so it's very clean, it feels very neat, it doesn't feel clunky to write in the language and to read the language. And it's type safe, so when you make mistakes with standard sort of, you didn't realize you misspelled the variable name sort of thing, it catches it for you at compile time. And then it's also built with testability from the ground up. So that's for where you're writing unit tests where you have code that creates a small part of your application, feeds that application inputs, and expects side effects and outputs of your application to meet certain criteria, which is another thing that is become extremely prevalent nowadays, where most of the very prevalent languages actually were not designed with that in mind. And for questions, please ask questions in the middle. I'll take them whenever. So I'm not the first language to try and solve a lot of these problems. So no-op is an example of a language where it aims to make everything testable regardless of how you write it. It is a dead language, unfortunately. It never had a compiler written, but it's an example. Also, trying to make type-safe languages, which feel smooth instead of clunky, is something that languages like Go have recently attempted. To handle null propagation, which has been called the billion-dollar mistake very famously, is something that has been handled in Swift, which people have been calling that Swift's best feature. And then also, something that I'm going to be building into the language since it's still very flexible at this point, it's been a goal from the beginning, is to handle diverging languages and platforms. This is where you have to build an app that's targeted for the web, targeted for iOS, targeted for Android, targeted for the desktop. And there's kind of nothing that you can do to get around that. So by building a language that can interact with libraries from other languages and compile to other languages, you can sort of solve these problems, and you can sort of create developers who can work anywhere on anything because they understand a language that works anywhere on anything. And once again, this is a problem that other languages have tried to solve, such as hex. It's actually pronounced hex, not hex. So hopefully, Wake can solve all of these problems and more, and in the process create a unique concoction that solves all of the things people lately have been interested in solving, and do it all very well. That is the goal. So here's Hello World. I think it's kind of mandatory. First thing you do when you're writing a language, when you're writing and learning a language, you have to do Hello World. So it should be pretty straightforward. You import printer, just like you would do in Java. And a class declaration looks like this, where you say every main is, every my class is. Basically, it's just a way of saving you some open brackets and closed brackets, which are really unnecessary, and they're always matched, and you're never nested. When you say needs printer, that means you're guaranteed to get a printer, and you're getting it through dependency injection, which is a pattern for testability. And then when you define this main method, it's very simple, very clean. You can just say printer.println hello world. So hopefully that's all pretty straightforward and pretty clean, and it's all type safe as well.
And printer is an instance?
Printer is an instance, yes.
What if you require multiple, would you comma separate them? Or?
Yes, you can comma separate them, exactly. So how to make a smooth static language is probably one of the more difficult and important things to do in Wake. There's been a couple things. So it's a very simple thing in my opinion, it's just to infer abstract methods. Languages like Java have a lot of extra keywords, and you have to make abstract methods on abstract classes where it's kind of all just sort of obvious. And saving the developer typing, making it impossible for them to write it down for it to compile, saves everyone typing and saves everyone code. Declaring void return types is optional in some languages. This is where a function needs to declare what it returns so that other code can use it properly. And you say, this actually doesn't return anything at all, you can't use the response from this function. And just having people not have to declare it is one of those things that just makes code read much better. Type inference, go ahead. Type inference is another thing where you can sort of figure out what the types are. Someone is working with data here and they're working with it there, so the compiler can figure out this is the commonality and this is what we can deal with. Clean constructors, you've seen that with needs printer. Needs printer is a constructor. And in a lot of languages like Java, you would have to say, public my class printer, this printer equals printer. Needs printer is clearly much cleaner. Easy iteration. This is something that, in C++ you still have to use for loops everywhere. In Java they have for each loops where you have to declare types and variables in it. Dynamic languages clearly win in easy iteration, and that's been one of my goals for Wake, is to have the same easy iteration, since so much of what we do as programmers is loop. And then array map literals is another example of where dynamic languages shine. JSON is a fully qualified data format right within the language. And being able to have array map literals built into the language will really improve the feel. And then lastly, and probably the most important thing on this whole slide, is to stop requiring variable names. Most of the time in a statically typed language, when you're working with two variables, they're of different types. And most of the time in domain-driven design, which is what most of us do nowadays, the two types are the defining characteristics. We will create a credit card processor and name it credit card processor. This is ridiculous. We can save people typing, have clear variable names, and have an expressive feel all at once if we just stop requiring variable names. So two of these things aren't quite in yet. Array literals are currently only the empty literals supported. Anyone who wants to help me to create the type inference or map literals be more complete would be welcomed. So, that's what does this mean from code perspective? So, say we have a class, Pillow Factory. It's just going to have a couple methods. This is kind of what you'd see on Java. It's already a little bit cleaner than Java because we're not declaring that it's public. We're not declaring that it's a void method. These are just declared as it is. But we're doing this awkward sort of create pillows num count. It doesn't read out very well at all. It gets even worse when methods get more complicated. Create num pillows between min num and max num. This is clearly not very good. One thing interesting you will see though is that num min and num max would read worse. In Wake, all classes are capital X. All variables are lowercase. And by doing this, you can create a variable name before the type or after a type, wherever it reads better. But still, it's not a very good improvement, right? This is much better. So this is an example of where we don't require you to give a variable a name. There's only one pillow in scope. It's a pillow. You would name it pillow if you had to. You can just call it pillow. And now your method is recycle pillow. And then to counter this, another thing, we can put right in the center of the method, we can say create num pillows. And one thing magical about this is that when you actually invoke this method, you would literally write create 5 pillows, create X pillows, create Y pillows. And then lastly, to solve the create num pillows between min num max num, which is by far the grossest on this slide, you can use this. Create between num and num pillows. Once again, we're using a type instead of a variable name. We have 2 numbers in scope. The only thing we care about is that they're 2 different numbers. You can use $sign in front of one and not the other. And you can embed the variable names, the arguments, right in the center of the method call. You wouldn't always use the $sign declaration. You can give them variable names instead. But sometimes, especially when you're doing algorithms, it can be sort of interesting just to use the $sign to distinguish these 2 variables.
So you could put min or max.
You could put min.
Just like you did.
Yes, all of these methods are syntactically valid. It's just showing the progression of going from old thinking to new thinking.
But wouldn't it be confusing if you had more than 2 numbers? Say you had a function which requires 10 numbers. How do you name it?
Yes, so I mean, in this example, basically your method name does tell you what they do. It isn't a very scalable approach, but there's some methods that always stay short. A great example of that would be setter methods. So you'd say like set max count. You had an old max count that's a num. You're getting a new max count that's a num. You don't need to give it a name. You can just call it $sign num, and it's very clear. This is pushing it a little bit, I will say. So here's an example of sort of a simple method in Wake. So you've seen method declarations before. Variables must be preceded with var, and that's because otherwise you wouldn't necessarily know what's a type and what's an alias. So we can say var start equals 1, and that's an example of the type inference that can be added actually really easily It's not quite there yet, but it's very, very easy to add, just at low priority. So you don't have to say var num equals 1, you don't have to say var num start equals 1, you can say var start equals 1. We can create a num array below that, and that num array is just called num array. The num open bracket, close bracket is actually the name of that variable. And then we can set it to this array literal right here, start and comma 2. Like I said, currently only the empty array literal is supported, but this is the income. So as an example of easy iteration, I think Wake boasts the easiest, fastest iteration of any language. So in this for each loop, we can say for each num array. And automatically, because we're mixing types and variable names, it knows to remove the brackets and create a variable named num within the array. It automatically detects if there's any conflicts in the variable names, and it will tell you that you can't do that because it's overriding a previous variable. So it's still safe, but it's actually something that Python and Ruby and all these slick, small amount of typing, quickly expressive languages would be very jealous of. And then lastly, you've seen before, print line num. Any questions on any of these features here?
So what if you're iterating through like key value? How do you
Yes.
handle that, or how does that handle that?
Iterating over maps, and in fact just iterating over like objects, having it be an interface is something that's in the works.
Okay.
I haven't really found a need for it yet, but there is an incoming syntax where you can say for each as at, stuff like that. And one thing I wanted to mention as well is that you can actually have any expression inside this for each num. It doesn't have to be a variable name. You can call other functions, and it knows automatically the return type of that function and can create a variable with the proper name for you. So you can have function calls, member variables, whatever you want in there.
Can you manually declare your own name for the variable though?
Yes, so that's incoming. It's a for each as, and then you can give it a alias name. So this is Tall's logo once again. So one of the difficulties in Wake is the testability thing. The biggest, one of the biggest real drives in making Wake is making it so that it's impossible to write code that can't be easily unit tested. And one of the difficulties in this is that it's a very academic thing to say, right? Like, how do you convince people of that? And we actually have a lot of difficulty just getting 10 people in a room to agree on what testability even is. So obviously I have to go over it. So I'm going to start by showing what kind of code we want to write and we want to be testable. So if you have a credit card, and you can get this credit card for each user and it's an object, we want to be able to just charge them. We don't want there to be any complexities around this. And usually people just write something where they create a credit card processor on the fly, they charge the processor with the various data that's needed. This is code that we love to write. It's only 9 lines of code. There isn't really much boilerplate in it. And it's untestable. And the reason why is that this credit card processor is always the real deal. There is no way to use inheritance or any other feature to have this function be exactly written like this and behave differently and not charge a real card, which obviously would be really bad if every night your automated tests ran and there was a bug in your automated tests that were charging someone's card $99 every day and you didn't realize it until a month later. So this is sort of the crux of testability, is these things that you want to avoid, you want to cut out of your program, and you want to write it like this. Anyone have any questions about the problems with this code? So there's a couple strategies that people will do to recover from this. And the first ones that people will think of are usually not the best approach. So people will switch on an immutable config app. They'll say, when the app is fired up, it creates this data that cannot be altered, that says things such as, I am in testing mode, I am not in testing mode. And based on this, we determine whether or not we're charging a card. And what this does is it actually makes code completely inaccessible to your test suite. You one day say, I don't want this happening in my tests. So you say, if the test suite is running, don't run it. And then one day someone adds in more validation. They add in something simple that says, make sure the credit card number is correct. You want to unit test that the credit card number is correct before you start charging it, but you can't because it's been tied in with this production-only code. You cannot test it. So people say, well, let's make it mutable. Let's say, at runtime, I can say, during the test suite, set testing false, set testing credit cards to false, so that I get the real code. Now it's no longer completely inaccessible. And the problem is exactly, we made it immutable in the first place for a reason. So now at runtime in your production code, something can fire that sets that thing that turns off all credit card processors. It can set that flag. Now suddenly your production server is running for who knows how long, making fake charges that don't go through. Similarly, the opposite can happen, where in your test suite, this code says, oh, I need to disable this and this test code, and forgets to. So now you're running the real code and you're charging real cards once again. It's not a good solution. So people will say, well, use a factory, and that factory can determine what type of object to give you. You give back a real credit card processor or a fake credit card processor. But the problem with this is that ultimately we're still relying on global data, and that global data determines behavior. And now we've just also made ourselves deal with factories, which is like the butt of every joke in software design. Nobody likes to use them. So lastly, people get really desperate and they say, okay, well, we're gonna replace the name, we're gonna take a name server and name the same thing as the credit card server and disconnect the server from the internet and create a fake API that matches the credit card. So you completely stub out the credit card server and use all of these precarious sort of complex tools to isolate it at the most outermost level you possibly can. And sometimes it's just a huge pain, especially if you didn't write credit card processor. How do you know how it connects to the internet? How do you know how to send it back data? So the way that people usually advise solving this, which is pretty universally agreed on in the Java world, is that you sort of box yourself into this model. You say, a credit card processor is not something that I create. I accept one. I, as a credit card, cannot function with a credit card processor. And this constructor here, public credit card processor P, sets that. So you can construct a credit card processor that's talking to a real credit card server. You can construct one that's talking to a fake one. And you end up, we've gone from 9 lines of code to 12 lines of code. It's simple, but developers hate that. You have all this extra boilerplate typing, and then you also have to manage this credit card processor and this constructor everywhere. So wouldn't it be nice if it looked instead like this? So this is an example of Wake. We've actually cut out a line of code compared to the original example. And all we do is we say that we have a credit card, that a credit card needs a credit card processor, and then when we charge it, we just charge it. This is how code should have been written originally, and this should have been testable. And if you code in Wake, it always is. So some of you may go, okay, well, nitpick. Technically we're reusing a credit card processor. We used to be creating a new credit card processor per transaction. So for those of you who are curious how you would create a new credit card processor, this is how you do it. You say that a credit card provides a credit card processor, and then you just extract a credit card processor out of yourself and then charge it. And this is actually also testable, because what you can do is you can create a subclass of credit card that provides a different credit card processor. So now you've got your test version of credit card, you've got your fake version of credit card, and libraries can automatically generate these classes for you. So yeah, how do we actually define this? So are there any things that we can say, like we've learned the lessons, this must be done in Wake for it to be testable. If you do this, it's untestable. So just a couple things. So global state is bad. Global state ruins your testability. You can't run 2 tests at the same time if they talk to the same global state. They need it to be in different ways. You just can't. Using inheritance to stub out behavior. If you have code that does something bad and you want to avoid it, the simplest way is to create a subclass. When you create a new class, you can keep all the behavior that you want from the original, and you can override just the method calls that do bad things. So then you can pass that in. Anything that it can accept a credit card processor can accept a mock credit card processor. That's how inheritance works. That's why we have inheritance. And it allows us to have a seam in between this object's behavior and this object's behavior. And we always have that seam, and we can always cut it and place something else inside. Also, static methods versus instance methods. So static methods are where you have a single class, and instead of saying new credit card charge, you would just say credit card.charge. You can only have one of them. It doesn't make sense. You can only have one credit card in your application. That absolutely doesn't make sense. There's times where it feels more intuitive, but you run into a problem. You can extend a credit card if it's a static class, but you can never inject it. You can't say that this code operates on a singleton and inject your singleton. It's just not going to happen. If it's a static method, then it's hardwired at compile time. And that means that you can't test it. So in Wake, you may have guessed, there are only instances, there are no statics. So lastly, we have to isolate the new keyword. When you say new credit card, you have a real credit card. That must be a hardwired behavior. There's simply no other way to do it. If you can't hardwire your news, you can't create things. So essentially what you need is you need a scene before and after every single time the new word happens. If you create something, you must be able to inject behavior right around that creation point. And that's why we have provisions. You say provides credit card. That allows you to extract purely that new keyword from your other code. So, as an example of using inheritance, this is written in Wake. As an example of using inheritance to, let's say we're going to test our Hello World app. So our Hello World app prints Hello World on the console. That console is, what was printed out there is inaccessible to any test suite. If you just call Hello World, it's going to print, you're going to see it, and there's no easy way for your program to verify that that was an input versus an output. So what we do is we create a mock printer class. By saying it's a capable printer, what we've done is we've said we're going to implement all of the methods of printer. We have to be a fully capable printer. If we don't implement everything, it's going to have a compile time error. And we're also not going to keep any of the behavior, because we don't want real behavior. We don't want the printer's behavior, we just want to be a printer. So then we create this public text. So we can say that our printed text begins as an empty string, and we're just going to store that for later. When they call print line text, we're going to take that text, we're going to add a new line, we're going to add it to our printed text for later. So now this enables us to create our Hello World class with this printer. When it calls print line Hello World, it's going to be stored in printed text with a new line. And then our test suite can say, printed text better equal Hello World new line, or something went wrong. It's a very simple example of side effects being isolated through inheritance. But nobody would want to write this, so there are libraries that you can use. So one of the first things I did with Wake is I wrote a unit testing framework and a mock-in framework. So a unit testing framework gives you structure for you to write your tests and automatically provide reports about what things passed, what things failed, eventually things like timing and stuff like that. And then a mock-in framework allows you to very easily create classes that create these schemes for you. So once again, we have a class declaration. We're testing main, so we're going to name this main test. We have another need here, so we say needs mock provider, and we're going to name it mocks. So that's an example of where we aren't using the type as the name. And then we say we're going to have a member variable, printer mock, and we're going to extract that out of our mocks provider. So that just sets us up to be able to create mocks, and then we have a mock printer on our object. Next up is we want to be able to create a main class, because that's what's printing Hello World. And to do that, it says you can't provide main unless you provide printer, because main requires a printer. So compile time, we say, okay, so we're going to create a printer, and we say we provide printer by providing that printer mock. So our printer mock that we just extracted out of mocks is going to be the thing injected into a main anytime we create a main. So second thing we do in our tester is we say var main from this. It's going to create a main, and the printer inside that main is going to be a mock. You can see too that this like tilde open bracket is a way of defining methods with arbitrary text. So this test method is named test.main.main prints hello world, and yes, this compiles. And then we assert in that method. So since there's no global state at the moment, you have to say mocks.use asserts. Once there's exceptions, that won't be required. And then now we have everything hooked up. We have our mock printer can now make assertions. We have a main that has a mock printer. And we're just going to call main.main, and that's what prints hello world. So lastly, we just say through Wakito's very smooth syntax, which is based on a job library, we can say mocks.verifyPrinterMock.println hello world. So this means that we didn't have to write our mock printer class. anytime you want to test with a mock, you don't need to do it. You can just import printer mock, and it will automatically detect that you're importing it, and it will automatically generate the class for you. So this allows you to, at any point, use a mock class that is exactly a capable class of a production class, and you can test case by test case determine what that mock is going to do, how it's going to interact with your code. I have a feeling there's going to be questions about this slide.
So is the method signature effectively executable code, like the actual test name is being parsed? Is that how you're defining that it prints hello world?
No, that would be cool. That's a good idea, actually. No, what it does is it's just in Wake you can have, actually I think it's any identifier, any lowercase identifier can be this, where you begin with a tilde and a bracket and close with a tilde and a bracket. So this just allows you to do things like you can have strings inside there, you can have bangs inside there, you can have question marks inside there, and we can do, so ordinarily in something like Java or PHP, you would have this like one word, test that main prints hello world, and it'd be all one word with no spaces, maybe underscores, capitalized letters and lowercase letters. So it's this very ugly thing. Here you can use any character you like, as long as it isn't a bracket and then a tilde.
So that's the method name.
That is the method name.
So hello world appears exactly once. So one thing seems to define the behavior, but then the other is invoking it. And
Yeah, so if you think about it, so main.main, all it does is it says printer.print hello world, right? So when we call main.main here, that is going to say printer.print line hello world. And then our generated class actually stores that method call for later use. So it says, something just called print hello world, save that in a data structure. And then when we say mocks.verify printer mock, it says, okay, so I'm looking in printer mock's data structures. And then when you say print line hello world, it knows what method it's looking at.
So you're verifying that the printer mock had the method called print line called
With the value
hello world.
Exactly. And this is based on Mockito, a very common Java mocking framework. And there's also JS Mockito, and PHP has Mockito, and there's a bunch of other ones. So it seemed like a good line to go down.
What's going on up there? So you needs provider, mock provider. So that's just saying it's going to get an instance of mock provider from somewhere.
Exactly. We're going to name it mocks.
And then what's this with printer mock coming out of mocks? That's saying mocks is providing a new instance.
Exactly. Yeah, mock.
So you're asking mocks to instantiate one for you?
Mocks instantiates a printer mock for us, and then it's stored in it's a member variable. So it's a property. It's a private property named printer mock of type printer mock, instantiated by grabbing it out of our mock provider. And then when we say provides main, if you had left it at that and you just said provides main semicolon, it would say error. You can't provide a main, you can't provide a printer. Main needs a printer. How are you supposed to provide a main? So then you have to provide all the dependencies as well. So this allows you to, in a test, know exactly what dependencies you're up against. So you know if somebody changes the dependencies, it doesn't just suddenly start using a live one. It has compile timed error and makes you go back and fix it. So if you just said provides main, it would say you can't, you have to provide a printer. So then we just say comma printer. But we don't want to return just any printer, so we don't end there. We don't say comma printer semicolon. We say comma printer dash, and then a bracket, so we can do arbitrary behavior. And we say return printer mock. And there's actually a lot of syntax in provisions. So you can say provides printer, caret dash mock printer, and that would know what class to swap it out with. You can also provide a class and specify what dependencies of that class will swap with other things. There's a lot of syntax and a lot of options with this. And this is the feature that needs the most testing and the most feedback of anything.
So you're saying it will have a local variable.
Yeah.
It will have a local variable called main. Every time it runs, that is an instance of main, and it will be provided with a printer, which is the result of that expression.
Not quite.
Okay.
So it's not always going to have a main. When we say var main from this, right there.
That's where you're instantiating it, or getting the instance of it
Right,
in the scope of that method call.
exactly. And printer mock, you could say this dot printer mock. It's a full-blown property on your class.
Yeah.
It's not public, but it is a property on your class.
So here, are we interacting with the IOC container transparently, or are we totally taking its place?
We're totally taking its place. And one thing I want to do eventually is I want to be able to wrap provisions from other classes. So you can say needs injector, and then you can say provides main, comma, everything from injector. And that way you'd be able to satisfy all the dependencies of main if they're crazy with very little typing. So like I said, this is the number one thing that needs the most feedback. I need to know what people find they butt their head against, what people find they want to use with it. An example is I've been tempted to do a with provided syntax, so that instead of writing provides main, comma, printer, dash return printer mock, you'd be able to say with provided printer mock from mocks, and that would automatically know that printer mock is going to be the thing passed into anything that needs a printer mock. So there's a lot of ideas here, and this is only really becomes apparent what's good and bad once you start getting into large applications. So this is like this. I absolutely would love any feedback on this, any concerns, any use cases you can see that aren't satisfied by this, and I will either let you know there's a syntax for it that solves it, or we'll figure something out.
And the less than and then the dash, does that basically mean from?
From.
Sorry, so I'm a little lost. How many functions are we looking at here? Just one?
Just one.
Just one. Then what's the one above it? That's just those requirements for the class?
Yeah, I guess you can kind of consider those functions. So those are provisions. So yeah, so you could say provides main semicolon, and that would mean that at any point you can say var main from this. Someone could have, let's say you're creating a class named main provider. Main provider would provide main, and then anyone with a main provider would be able to say var main from main provider. So this allows you to say, I am capable of providing this thing. This thing must be new. It's a credit card. We need more than one credit card in our app. So I'm going to provide that credit card. And that's going to handle all the dependencies as well. So main prints hello world. It can't print hello world without a printer. So when we defined main, we said every main needs printer. Because of that, if you tried to compile the program with only provides main, it would tell you, you can't provide a main. You can't provide a printer. Main needs a printer. So then we say we also provide a printer. And then the dash syntax with curly braces is kind of like a function. So it allows us to stick arbitrary behavior that says, what's the code, what's the behavior you're going to do that creates the printer that's going to get stuck inside the main when you create one. So right here where we say var main from this, the first thing the compiler does is it says, okay, so to create a main, you need a printer. Can this class create a printer? Yes, it can. So it's going to say, okay, so call the code, return printer mock, save that in a variable, then create a main, and put that printer inside the main, and then assign that main right here. So you've got a main that has all of its dependencies met. You got to control how all of them were created, and that allows you to swap them out with mocks. This is definitely, this is very new. There is no new keyword in the language. That is a very distinct thing about Wig.
Just one other question. What's the background on the word is, and why is that in there instead of just saying every main test?
Just thought it was more human readable.
Okay.
Yeah. And there's also an idea of, to create a singleton, you would just say the main test is,
Okay.
and then it would just automatically know to only ever instantiate one.
And then always return that one from now on.
And if you wanted to instantiate another, you would just create a subclass that says every non-singleton main test is. So what kind of features are in Wake? You know, is it pretty feature complete? Is it really tough to use? This is the features that are in and the features that aren't in. So we've got method overloading. That allows you to say print text operates differently than print none. We've got inheritance, of course, so you can extend classes. You can extend classes without including the behavior for things like testing. We also have lists. I've decided to get rid of 70s variable names, or not 70s, 70s keywords things like volatile, abstracts, virtual, void, things like that. So one of them is array. It's just called lists. There's still linked lists. There are linked lists, and there are linked lists. We also have file I/O, so you can create files, delete files. You can read files. You can write files. And we have generics. So this is something that Java, C#, and Go all launch without generics. And if you code in Java, you know the problem of erasure. Erasure was this original sort of hack done to make generics work with pre-existing libraries, and it doesn't work. And there are also runtime costs from having a language that was originally written without generics. So those runtime costs don't exist in
Michael, sorry, on lists, does that include hashes?
Hashes, there's a very, very simple hash map class that's created, which is very slow. It's a 9-event implementation. I want to make one that connects to the native JavaScript hash map performance. You can still use hash maps, they're just not very fast. And that's one example too of where literals, having hash map literals is something that I do want. So you can just define, this is a hash map, these are the keys, these are the values. Be able to do it in one statement. There's also incremental compilation, who is one of the most difficult things to include in Wake, is the ability to compile individual files at a time and then hook them together at the end. But that is built, and there's also a build tool that comes with Wake. It's just written in Make, very simple, that automatically says anytime a file changes, recompile it. Any files that depend on it will automatically know if the interface changed and recompile all of those files. So it leads to very, very fast build times because the compiler is already fast, and then you have really good incremental compilation support. There's also a library that provides compile time reflection. So reflection is often used in Java. There's a big difference between compile time and runtime reflection. So in runtime reflection, you're able to just accept any variable of any type, and you can figure out what it is, and depending on what it is, when the program's running, you can do different things. This allows you to create a lot of fancy things like JSON serialization. Unfortunately, that doesn't exist yet. That is a planned feature incoming. But at the moment, what you can do is you can do compile time reflection. So there's a library that you can say, here's a source code file. I compiled it into this interface file. Read this interface file and tell me all of its methods, all of its properties. And by doing that, you can generate source code for classes such as the mocks. So this allows you to have classes that are automatically generated and syntactically correct, work with the type system, and all of that. So these are the other side of the list, the features I don't have. Some of them, pointers example, are something that I probably won't include. Pointers are good for optimization, but they're also inherently very unsafe. They inherently break down a lot of rules of like memory corruption becomes a thing. They become sort of the worst bugs to create. You have to create very complex rules about defined and undefined behavior. It does create for a very, very fast language, but it creates a very risky one. So I don't plan on ever including pointers. It's not to say it won't happen, it's not planned. Reference types is another example. This is how a lot of people get around pointers. A lot of the things you use pointers for. You could say, I've got a variable which is equivalent to this variable. They've changed together. They are referencing each other. And to be honest, I've never really found a suitable way of incorporating it that really makes many improvements to any programs. So they're just not in yet, and I don't know if I'll ever include them. Non-virtual methods aren't included, and this is for a very good reason. Virtual methods are hard-coded calls in your code to other code. It is that hard coding itself which breaks testability. So I have some really cool ideas on how to use immutable types and some intermediary language to potentially make the compiler automatically figure out when it could have been virtual. When it could say, oh, you haven't tested this, you're not testing this right now, so it's going to be non-virtual. But that's, non-virtual methods explicitly will never be in. Multiple return types is where you say, I want to get the minimum and the maximum out of this range. Give me a number list, I'll give you the minimum and the maximum at once. Sometimes you do it that way because it's fast to figure out. You get both of them at the same time. Once again, I've just never really found a use for it. Never really found code get cleaned up by it. So that is a feature that is not in Wake. Immutable types. This is a very important thing for type safety and something that I really plan to include soon. Basically, by making every variable immutable by default, you save yourself a ton of bugs. Most bugs happen because things happen in an order different than you expected. And by creating a variable that can be altered as the program runs, you've opened yourself up for it. Additionally, there's times where you've created a variable that you never change, that the compiler can't figure out. And it's pretty convinced that it is very likely to change, and because of that, there's all these things that the compiler cannot do to optimize it. This is why functional languages are so amazing, is they have just immutability everywhere. So making types immutable by default is something I don't have yet, and I do want to add.
So it'd be like an implicit final keyword?
Exactly. You would have to say, and this is actually a great point too, how often do you really change your parameters in a function? If you get passed values as a function, you very rarely modify those. It's a very confusing thing to do. It's a very bad practice most of the time. So having them default to immutable actually wouldn't break many programs. Of course, Wake is still in that process of being refined, and you may find your programs break because of rules like this months later. This is an example where you probably wouldn't find much of your program breaks. So the only real thing is making properties and making variables you define immutable, or not immutable by adding a keyword. Anonymous classes, I can really see in hindsight why Java needed them so much. Java really needs anonymous classes because everything's a class, everything talks through classes, there's no functional programming. I don't plan to support them, and in fact my syntax of every blah 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 goes directly against nested classes. So it's very likely I will never have anonymous classes, but functional programming is something that the type system currently knows about, even if you can't define closures and you can't generate closures yet. So that functional programming is on the way as well, so hopefully that will eliminate the need for anonymous classes.
Do we have a way to namespace classes? Because if I've got 3 different nodes of various types lying around, I want to be able to say which node I'm pointing at.
That's actually a great point. I don't have namespaces yet. I really do want to do packages. Ideally, in the end, you wouldn't have to import printer. You would just import I/O, and that would give you file reading, standard out writing. It would give you a bundle of classes all at once, and that way you don't have to manage import this, import that, and then you get unused imports everywhere. So that is something that isn't built in yet, but it shouldn't be too hard to add. And once again, it's planned. It's upcoming. Lastly, pattern matching. I don't know if anyone here knows how Scala does pattern matching, but they basically use inheritance to say you can have a class, or you can have an object, and you can match against its possible parent classes to move it up the inheritance tree and then get values out of it at the same time. And I think that's really neat, and I don't think that breaks the principle of Wake, so I really wouldn't mind adding that. Okay, so that's kind of what it has, what it doesn't have. Here are things that any of you who are brave enough to hack on the compiler, who can alter the source code, who knows C++, knows compiler theory or wants to learn it, I could use help on all of these things. So the top one is the most important thing. Compiling to other languages should be done very soon because it's a very large idea. There are languages that have done it, so we're not, we have examples we can follow. But the sooner we do it, the better, because that's going to have widespread consequences in other features of the language. Exceptions is something that I have mostly coded. Basically, all I'm lacking at this point is the way to compile exceptions into JavaScript, because we have stack traces, but they're minified stack traces. So at this point, I have a branch which you can create exception classes, you can throw exception classes, you can catch exception classes. You just can't compile it yet.
Did you say JavaScript?
JavaScript. At the moment, everything compiles to JavaScript.
So, okay, so not included in that. So additionally,
Runtime reflection I've already talked about. Closures I've kind of mentioned. Generic inheritance is a very important thing. It's going to be super easy to add. Basically, you can say, my class extends a list of objects. My class extends a list of credit cards. And that's an important feature to add too. And then also an important one, which I haven't gotten around to yet, is just making a base object class. Since everything is type safe, the compiler has to always know what the data structure is and what you're working with. And Java and C# have really proven the value of having a single data structure that represents anything, and a certain set of commonality that anything can fulfill. And being able to have numbers, text, credit cards, and everything fulfill that is an important thing, and that's honestly pretty easy to add to. I just haven't gotten around to it yet. But a lot of you probably don't want to hack on a compiler, so here's a list instead of libraries. So these are things, if you want to try Wake, if you want to write Wake, these are the things that I would love help with. Some of them require integrating with JavaScript, and that's kind of a gross hack at the moment, but I can show you how to do that. And then other ones, such as the templating library, don't require any JavaScript at all. I encourage all of you to look at this list and look for something that piques your interest. And find me and talk to me. Say, how hard is it? You know, what am I up against? You know, and then work with me. There are some really important ones. Being able to do sockets, that's a tough one to do because you have to write JavaScript that connects with a compiler. But being able to do sockets opens up a lot of these other things. So a web server and hash install RPC and database interaction are all required on having socket I/O. Yeah, regular expressions would be a very important one to get done soon. Also package manager. Package manager is a hugely important thing. I've got a couple libraries that I've got WUnit, I've got Mockito, I've got table reflection parsing, I've got the standard library, and all these things are sort of bundled ad hoc at the moment. And being able to create a package manager would be hugely important. There's an interesting note too I want to add about hash install RPC. So hash install RPC is a very, very cool thing that Java has. RPC is for remote procedure call. So what you can do is you can define a class that has all these behaviors. It has these inputs and outputs, and you want to run it separately. You want to put it on its own server. You want to have its interactions separated. So you get to seamlessly have classes generated for you that act exactly like the other class, but secretly pipe information across to another computer. That computer then calculates things and pipes things back. And by doing this, this is incredibly powerful when mixed with things like multiple language compilation. By doing this, you could create a PHP web framework that has state. So
That would also kind of depend on the running, wouldn't it? Otherwise, you've got to wait for the retrieval effect, because otherwise you have to wait for the call out and call back.
yes, threading would be important. Just worth noting that at the moment it runs on Node. Node doesn't have threading.
The Hessian implementations we've seen are blocking calls.
You need a,
They're not done in threads in many cases, they're just direct.
it definitely would be best to do it threaded, but it wouldn't be it would be very important to do it early on, or you'd find yourself having like a sea of bugs. Oh, I was working on a single thread, it worked just fine. Angular integration would also be super cool. You know, I think a lot of us here use Angular and like Angular. It requires a lot of JavaScript integration, so it would be very difficult, but it would be super cool. And yeah, I mean, so many of these things are just so important. So I'm going to leave this up for you to continue to look through it if you'd like. That is the presentation. Thank you all for coming. I hope it's been insightful. I hope it's been, taught you why Wake is potentially the answer to a lot of modern problems. Why Wake is easy to use, solid to use, scalable, maintainable, and the testability that it offers is seamless, and you can't not use it. It's seamless, and it just works, and you just have testable code.